Alright, today I'm going to be teaching you guys about integration by substitution. Very fun topic. You might notice I'm skipping over 6.1. It's because it's a very ambiguous section, and I figure you all guys will learn it from Miss Masson very soon. Anyways, we're just going to do a quick review of the indefinite integral. We've all seen this before. This is the whole equation set up here. You got your integrand, their f of x, and your d of x, that dummy variable, as she likes to call it, and then our integral symbol. Notice for the indefinite, other than the stuff we've been doing, is no limits of integration. And also the plus c, constant of integration. And then a quick example, just refresh your memory. The indefinite integral of 2x squared dx. Basic power rule, add 1 to the power and divide by that new power. And x squared plus c. Pretty simple stuff. And to move on to the new subject, integration by substitution, we jump on down here. And basically, substitution is the method of turning an unfamiliar integral into one we can evaluate. And the example I'll be doing to show this is as follows. The first thing you want to do is substitute. Of course, it's the name of the method. To do this, we got to use u's and du's. We got to turn this unfamiliar equation into something of the more standard variation of this, where we can use the simple power rule. So basically, you want to set something here as u, and what we're going to do is we're going to say that u is equal to x plus 3. And now we got to figure out what du is. And it's pretty simple. Just take the derivative of u, which is 1, dx. So now we've gone this far and have our substitutors, which we will substitute to be able to solve this equation fairly easily. From here, we say that 1 times dx is simply dx. And now we can substitute and solve this integral just as if it was the one we did in the beginning. So to do this, simply write equals. This will become, based on these substitution variables we have here, u to the 4th du. We say that u is x plus 3, and it's x plus 3 to the 4th. So we just take u to the 4th, and then du we said was 1 dx, or simply dx. So we replace dx with du, and we replace x plus 3 with u. So now we have u to the 4th du, and we can solve it just as we did in the beginning with a simple power rule. And we get, add 1 to the power and divide by your new power. And don't forget to add your constant. And back here, let me just go ahead and add this. So we get the indefinite integral of u to the 4th du is equal to u to the 5th divided by 5 plus c. And now we just simply plug in what we know u to be, x plus 3, and the answer we receive is x plus 3 to the 5th divided by 5 plus c. And that is the first of several examples to come, and they'll progressively get much, much harder. And yeah. And with example 2, going to be a little bit harder. Still not quite as difficult, but we get to see a lot more of our properties learned previously in this example. So let's just give it a go. Substitution, of course, we're going to have to figure out our u's and the du, and substitute them back in and solve our integral. This is very unfamiliar equation for us to be able to integrate, so we need to make it a little more familiar to ourselves. So what we're going to do is we're going to say let u be 3x minus 1, and du is of course the derivative of this, which is fairly simple. It's just 3 dx. Or if you like, you could write it as du dx equals 3. That way you don't get all freaked out by it. What's this dx doing over here? But we're going to eventually need it over here anyways, so I just automatically went right to here. And now that we figured out du, we need to figure out what dx is equal to in terms of u, so we have something to plug it in for dx. So to solve for dx, just divide by 3. You get dx is equal to 1/3 du. You could leave it as du over 3, but I like the 1/3 for, as you'll see later, why it comes in handy to have it like that. Basically what we do here from now is just plug in what we know and just go with it. So let's go ahead and plug it in. Keep our square root, keep our integral sign. Now we have the square root of u du. But it's actually 1/3 du because I'm a retard. We simply plugged in u for 3x minus 1 and 1/3 du wherever we found our dx at. And of course this is being multiplied. So we see a constant, 1/3, and we see a multiplication. Put the two words together, and what do we have? Our constant multiple rule from way back in derivative land and integration land from last chapter. So we're going to just simply move the 1/3 out front and leave the square root of u du. Now that we have this, we can simply solve this integral now because it's a very familiar function. All we have to do is change it into a power rule, and we'll be on our way. So keep everything here, and we're going to change u to the 1/2 du. And very, very easy now. 1/3 times the integral. Actually, we'll just go right from here. Let's add 1 to the power. So 1/2 plus 2/2 is 3/2. And then we got to divide by 3/2, or I like to just multiply by 2/3. Now that we have this, we can plug in our u, which we already figured out back at the beginning. 1/3 times 2/3, and then we plug in our u, 3x minus 1 to the 3/2. And don't forget plus c, and you can bring it down all the way if you want. And there we have it. You could expand this out fully, but it's pretty much unnecessary because, well, I mean, you could just do, 2/9 or whatever. That's pretty much it. I mean, 1 times 2 is 2, 3 times 3 is 9. You get 2/9. And then you just leave the rest of it the same. 3x minus 1 to the 3/2 plus c. Really don't need to keep going farther though. And there it is right there. Because I'm stupid and didn't realize that it went off the camera. So we're back with our next example. This one just a little bit harder than the last one. You got more things to consider. And we're still substituting, so let's just get right at it. And then after this, we're going to move into our good old friends, the trigonometric functions and fun stuff like that, where it gets a little more difficult. Alright, so we need something to choose as u. This time we have two different separated terms here, and we got to choose which one is going to be the best for us to set as u. Usually you just want to go for the hardest looking term. Obviously, it could be opinionated or argued, but I believe here that the square root of 1 plus x squared is kind of like the harder piece of this puzzle. And so we want to set u as 1 plus x squared. And now we have that, just take the derivative of it to get our du is equal to, 2x dx. And